So the the password service thing, like data sovereignty, is pretty important in that space. Um, and what I wanted to talk about was I just keep on coming up with ways that this consensus based model with like very simple nodes that are treated very harshly. Like the first sign of fault, they get kicked,
Mm.
and I've got a very low latency, highly performant Byzantine fault tolerant algorithm synchronizing them. If you treat the node as the basic repeatable unit of computing, and then you treat the blockchain that they form, the blockchain network that they form, as the reliability primitive. So that's the layer that reliability occurs at and no other. Then you can start to present any cloud based service using that. Like that's like a molecule. Like if the node was an atom, you can make a molecule that's reliable and tuned for a specific purpose, and you can present it as a highly reliable system, which is what the cloud providers would have you believe. You like it's like you pay us money, we'll make sure that these things are reliable. You don't really know that it's reliable. You just a lot of the time sense that it's probably more reliable than what you could do, and the price is sort of close enough, and so off you go. But in reality, they have all kinds of faults that are hard to accuse them of, like latency issues, stalls, torn connections. Very hard to debug. It's like the most opaque type of system imaginable. An S3 compatible bucket. Like, who makes a transparent S3 bucket?
I agree. So if you take back to basics, um, confidentiality, integrity, and availability, they offer confidentiality through a supply chain of certs. Fine. Integrity, yeah. They wouldn't have a business if the actual data was getting messed with. Availability, however, is the big one. It's like they can yank you. Like, my current problem, you can just
Yeah,
get a rug pull.
yeah,
And it's like, we're not giving you your data. Yes, this is your data, but we have
yeah.
it if you
And
don't.
then you end up talking to a machine, and the
Yeah,
machine is you're like log a ticket. Ah, fuck, dude, come on. Like I need my data now. I don't need it when you get to it.
right, right. Which is why, in the thing we were talking about before, you were reverting to, hey, I'm going to keep my data locally.
Yep.
Um, but that was about availability. You didn't want a rug pull, but
It
that puts
was
the onus
it
on.
was yeah, it was availability, accessibility. I didn't want to be rug pulled, but I also knew that the chance of an external actor gaining access was higher because I could be subject to like a mass hack. And
Well, yes. Well, that comes down to confidentiality, doesn't it?
yeah,
Um,
because now all the precious things are in one spot. And so you're like,
yeah,
if I had the resources, where would I want to hit? Probably
and
the place that
it's
stores
also
the keys.
it's also things like without anyone knowing, and it comes out 10 years later, and someone gets a Pulitzer Prize for discovering it. AWS has actually been talking to the NSA and giving all their information.
Exactly.
To,
You just don't know. You just don't know. And um, what am I getting at? I'm starting to see that there's two. I think it sounds sort of a bit sort of tinfoil hat when I say it, but for a long time, like 2 decades, I felt like the internet made a couple of wrong design choices. Like it was all going great, and then data centers turned up, and then it sort of was less great. Um, and one of the so the first issue is that the problem of high availability and resilience and confidentiality, um, and I won't say integrity, but I would consider a resource not available if the integrity was faulted. So,
Yeah.
basically all those properties of a system that it's not considered working if it fails at one of those. That's what the cloud providers purported or promised. And then along comes Bitcoin and delivers on all of those except for confidentiality, but gives you a weird sort of a sideways version, which is like, well, it's actually more private if you do this thing. And then, when we deal with what we're talking about with blockchains, which is like this permissioned little group of, maybe 6 nodes, and you're like, that's my group, and no one gets to see inside it. So, um, there are an unlimited number of ways that you could offer a service as a cloud provider that promised to have those CIA properties, but there's a vanishingly small number of ways that you could offer that service transparently, like in a way that you could be transparent but not degrade the properties of your system by exposing its inner workings, like
Yes, a confidence level.
well, what's the word for that I'm looking for? Like to expose all your innards on the internet and be confident about it. So there's no like layers upon layers of stuff that you're not sure works, but you're like, if we slap enough of these layers together, we're going to call that safe. If it's like, no, there's this single unit, a standard unit that's highly tested and that's fully exposed, and that's that.
I think the word is confidence. It's confidence that you're doing exactly what you're saying. And you're right to, if I can, rewind a couple of minutes. In the design flaws, we went from an internet which was designed to survive a nuclear war.
Mm.
And so availability was the thing and integrity was the thing, but confidentiality was, hey, to the winds. And then layer onto that, well, we've got this massively distributed system. Let's concentrate a lot of that system in data centers.
Right. So,
And
like,
then,
let's make the place to nuke first.
right, exactly. And so now there's literally lat longs that if you nuke, it would take out a good proportion of everything that's done
Mm.
on the internet. But then you move to the crypto realm where, well, okay, so now we're compromising on confidentiality because everyone's got to see it, but you've got availability
Mm.
because you don't have a target.
Right.
Um, so there's been a number of design decisions, let's not call them errors, but design decisions that have compromised those.
Traded
Now,
away. It's traded it away inadvertently
right,
through
right.
iterative, many small steps, and then we look back and we're like, we're pretty far from home.
Yeah. Now, what I'm seeing, and I've mentioned a few times about these sovereign states who really want to have their data sovereign, as in, by that I read they can't have a rug pull. They can't be worrying that another state is going to have a look at their data. So,
Yeah, right? There's a
um,
problem.
and the only way they can think about it is building their own data centers. And it's like, ugh, oh,
Yeah, let's
okay.
bring the problem.
Yeah, but
Let's
that's
bring
that's just scaling down the same problem, isn't it? It's
with
the same
less
design
ability to solve
decision.
the actual problem that the cloud services delivered. So you've removed all the expertise, knowledge, and experience that goes into making sure those things do perform.
Right,
And
right, but
then, yeah,
yeah, but then you're taking it down from like an AWS level in multiple countries, and therefore under the jurisdiction of a number of different countries. And you're saying, okay, let's have basically AWS inside of one country. But then you go down one level and you think, well, okay, I'm a company inside of this country. And yeah, data sovereignty, that looks great. But I don't trust my government. And so you're just shifting the scope of where the problem is. You're not
Yeah,
actually fixing the design problem.
the devil came with you.
Yeah. Yeah.
The devil came with you. So, what I was getting at was that I've been going through, in broad strokes, some of the popular cloud services. S3 buckets are an easy one, and email's another one. And I see no reason why you can't revamp the service so that you can offer S3 like or S3 compatibility, but using these blockchains, so a little blockchain network per bucket type of thing. Because there's another design flaw that comes with these buckets, right? So let's say, okay, you can make a bucket, great, you've got it in a way that you can expose the architecture, you can expose the logs, you can get a full copy of your bucket so that you can actually run it on your own hardware, and it's the same bloody thing, so that you can make a bucket that's hybrid, it's in the cloud and it's local, and if one goes offline you can still talk to all those things. The second class of design error is this strange pull to put every user's data in one single place. And I don't know exactly why that has persisted. I know why it started, because of price. But price is, it's still there. And where I'm going with that is that, okay, so you got a bucket, you made it out of these blockchains, and it performs great for small levels of stuff. But then if you hit it with like a country's worth of data, it's probably gonna sweat, right? And our designs aren't really meant for that. But the issue there is that each individual user only makes a small amount of data, relatively speaking. And so if you split in a bucket, you typically partition it by user or by customer account or something like that. And so if you split the whole bucket so that each customer has their own bucket, then the performance requirements of that service become the performance requirements of that single user, which are typically pretty easily met by, a couple of half-assed Docker containers most of the time.
Right. And this is, we were talking about something that's really neat, and I really enjoyed thinking about 2 calls ago, when we're saying that, hey, you could get 3 nodes, and it doesn't matter where those 3 nodes are, but you've got some level of availability, because there's 3 nodes. If one goes down, rebuild a third one from the other 2.
Right.
You've got integrity, because you've got the hashes, and nobody's messed with it.
Yep.
And the confidentiality is whatever crypto you feel to put on the top of it.
Right.
But the interesting thing was, we've got our data. We don't need to offload that to anyone else's data.
That's the thing, right? That's the core principle.
That was a big one.
So in the S3 model, I think it's a very powerful thing to offer an S3 bucket service so that people can migrate their existing applications over painlessly, but it's running on a node or a blockchain so that they can actually take it with them. So they can take it from the hosting service and pull it local, or they can run it between multiple hosting services, their choice. And then you can dial the costs up and down, because the billing plans for S3 compatible services is so intricate now. But really, it's just like, well, what's the core cost? It's the computer, it's the storage. How many do you want? Where do you want them? And how would you like that to be balanced? That's a that's a fairly simple thing that does all the stuff that the real big, complicated people are doing. And it's like, you want to bring your own hard drive? You got some disk space lying around your home that you want to be your backup of last resort? Sure, plug
Well,
it in.
this is where the dark age comes in because what why what's the value add of AWS? It's like, okay, so it's a single interface, sure, but it's also, you don't have to worry about security. If you're so inclined, you probably do need to think about security.
You should worry
But you
about
just
it more. If you can't see it yourself, you should worry about it a whole lot more.
exactly. But you're just you're offloading all of that load onto AWS. You
Yep.
sort it out,
Yep.
and I don't really care.
Right.
But that's not very cost effective because AWS has got their infrastructure and their people to pay,
Mm.
their shareholders to pay.
Mm.
So it's not a basal rate of the
Mm.
compute.
Mm.
Now I've got right now, what, 3 computers running, and they're probably just ticking over.
You've
And
got
that,
spare space, so we should
right,
be able to make a program that can analyze. You install a little service on each machine, and it reports back to the management chain how much resource you've got available and what your typical usage patterns are. Then we use an LLM in conjunction with you to balance stuff out to find the best solution using natural language and goals.
right. Now here's the interesting thing about data sovereignty. Data sovereignty really comes down to um, your key security. If you have um, a decent enough security on encrypting your data, it doesn't really matter where you're getting the compute and the disk from, because they can't rug pull you because you've got multiple nodes. And in fact, diversity of nodes means that the rug pull becomes increasingly impossible.
So, are you implying that self sovereignty can be tampered or dampened down a bit, tamped, if even if the compute was happening offshore, like on GPUs hosted in Texas, so long as the data was hosted by you, or you were a participant in a blockchain network for your data and you were always up to date, that would equate to enough sovereignty?
Yeah, that's where it's going with this, and
So your
I'm just
question you
talking
need to
through
find
the.
out is, how much do they care about the anti-rug pull ability? So the denial of access to the data versus the confidentiality of the data, like that nobody can see it. And you'd sort
Well,
of want to say, well, I'll stop talking after this point. You'll sort of want to say that if it's a government and you're trying to be transparent and anti-corrupt, you kind of want to take advantage of the fact that you have a system where the internals are shareable, because the majority of data processing systems are not shareable, particularly at the country scale. But if you could share it, that I'd like to imagine that an anti-corruption government would choose to share it, and therefore, to further your point, maybe you don't care about the confidentiality as much as you care about the denial property.
correct. So long as now, let me try and be precise here. So the conversations we've been having in East Africa are largely around, we want to take data in country. That's a phrase that I hear a lot.
Right. But do they
Now,
say they also want to take compute in country?
well, I don't think they're being precise enough in what they're
Right.
asking
But,
for.
well, because I mean, there aren't really any other systems around that you can take just the data but have the compute be somewhere else.
Right,
Right.
right. And why do they want to bring it in country?
Right. Right.
And the argument that is usually given, or almost always given, is data is being used as a kind of neo-colonialist way of, holding them at risk of a decision made by another country or another organization.
So it's the denial that they care about as opposed to the visibility.
The visibility, I think they take as read that you can encrypt it, whatever data, but
Well,
it's
no,
being
it's like if you were getting it processed offshore, how much do they care about that? Like, can you find that out from them? Because those are two very different things. Because if you're okay with it being processed offshore, I think that so long as your processing mechanism is switchable, so for example, if you had a standard format by which you could invoke computation upon your data, you could run it at the cheapest data center, which may happen to be in Texas, but come a political shift, you can, without any loss of service, switch that load over to somewhere in the EU. And what you do there is you say, well, there's this massive capital cost to getting a data center up. And we know that right now, it's like the world's first fusion reactor is going to be horrifically expensive and terribly inefficient. But give it 100 years, and it might be the thing that powers your wristwatch or your implant or whatever it is. And so, the real strategy to save your money is to, first of all, make sure you've got data sovereignty insofar as you own your data, but then take advantage of, because there's a colonial war happening offshore. No one's even, you know, China versus America versus EU versus everyone, and they can just sit back and watch. It was like World War II, and then you've got Tanzania watching World War II, being like,
well, what happened after World War II? The British Empire collapsed.
yeah.
So
So
you know,
it pays to be involved, like to know, but it's not your fight. And why would Tanzania online a bunch of A100 GPUs at horrific cost because there's a squeeze on for pricing when you can buy the compute for a pretty reasonable price, and then you wait until the hardware comes down to being cost effective once the dust starts to settle, and then you pull the compute back in to your country for 10% the cost. But
well, I think there's so if we look at carefully what they probably should have said, high on their agenda is that they don't want to be exploited. They're done. 200 years of being exploited. They don't want to be
more,
exploited
300.
anymore. 300, yeah. So by exploitation means access to that data, someone else is data mining your shit. You're not getting anything back from that. No, they're not cool with that at all. The second thing is they don't want any attack vectors from an uncertain world. Maybe the US or maybe the Chinese, or who knows,
Right.
even the Brits or the Taiwanese
They
will.
don't want to squeeze. They don't want to be
Yeah,
squeezed. Yep.
yeah. They don't want an NSA style vulnerability. Now, their go-to at the moment is, I think they've got about $10 million building a data center, but it's one data
Right.
center.
Yeah, and that's probably still vulnerable to ransomware,
Right.
because the issue with having all your data in one spot is that if you lost control of that, which is possible,
Right. Right.
then
And then you
you're
come to
really up shit creek.
and then you come to costs. 10 million for a data center is not much. I mean, I've built two that's cost more than those. Um, so we're not talking about something you could, this is not tier four. And so you put all your eggs in one basket because you want all your eggs and you don't want anyone else to exploit your eggs, and
Yeah,
or see even how many eggs you've got, but you've still
yeah,
got it in one basket.
yeah,
So again, trade
yeah.
off.
So it would be great if you could find out precisely what it is they care about and if they're willing to get the compute outsourced, because depending on their answer to that, um, exposing your data is a spectrum, and you can do things like you can obfuscate the data that you're having processed so that you don't have access to the real data. You just have a very simple way to deobfuscate it, by like replacing names with really long random IDs and things like that.
Correct.
Like there's plenty of techniques that you can do it. I just strongly recommend doing the AI processing offshore, because it would be pure wasted money to buy AI processing equipment right now because you wanted to use AI locally. It's like just wait. Like no one knows where this is going yet.
Yes. The caveat to that is they still have a deep suspicion that somehow California is going to end up exploiting all the interactions, and they get nothing. Remember, that's number
Right.
one. On
Yeah, okay. Well, look, if they really want to just run their inference locally, fine. But it would pay to know where they land on those things, because everyone feels differently about those types of questions when you really dig into it.
well, I'll go back to a man who's in charge of building that data center. Um, there's realistically, he's quite far down the route. So I think this would be like an add-on, um, but it is. I I don't think they're being clear enough about what they mean by data sovereignty.
Yeah.
Um, and the obfuscation point that you made about a minute ago, I think, is the clear one when that obfuscation means that you might have shards on, completely separate nodes that are running in consensus and then sharing just the bits that they need to other shards in order to come to a conclusion on the data.
Yeah.
Because that is really difficult to take out and really difficult to. You'd have to own each of the networks and break the consensus and the crypto of each of the node networks that built up the shards of anything that you do.
Yeah, I'd want to steer away from shards
Mm-hmm.
because it's best to make it a whole different blockchain,
Mm-hmm.
because sharding again is a technique to cover the sins of centralization. It's like you tried to have one database for everyone, and now everyone turned out to be too many for your hardware, and now you need to shard. The correct,
Maybe shards the yes, I agree.
right,
Maybe shards the wrong word.
right.
It's the distribution of
Separation. You mean separation?
separation.
Yeah.
Separation.
So
Yes.
the left hand doesn't tell the right hand what it's doing,
Right.
and
It's need to know. It's
yeah,
like um, you don't
separation
need
of
to know.
concerns.
Yeah. Maybe there's one concern which is on one network and another concern which is another network.
Yeah,
Occasionally they need to share information, and that is controlled
yeah,
by
that's
each
done.
network.
That's done locally at the data
Yeah.
center. Yeah, and so the burning question I want to know from these guys is how willing are they to expose the internal mechanics of their data processing systems to the people that should own them. Like, for example, everyone has health records. The health record should be a dedicated blockchain. There should be one node from the government, one node that's a backup run by the government, one node that's for the person, and one node that is for the doctors
Mhm.
or the hospital.
How much would they know? I'm going to ask the question and check in with them. But that kind of there's a dot 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 there, which really is. Do you mind the computation going down so the users are penetrating down to the SSD that is running on?
Yeah, well, that's the level of granularity that it should be, and so one of the ways I want to expose that in our hosting infrastructure is, for example, Fly.io runs these different regions, right? So there's like 46 regions, like anywhere from Mumbai, Tokyo, all these places. They have Fly exposes their capacity. It's like you could feasibly start 2,000 machines right now with 1 gig of RAM each, and that fluctuates day by day because what one of the principles that Fly appears to be passing through is that they are raw hardware. They don't try to hide it, which is very different to what Amazon tries to do. Like Amazon tries to abstract away all hardware, but Fly is like, no, no, here is the hardware, and this is how much we've got. And they turn they turn tin on and they turn tin off based on trends within specific regions. And they use pricing as a means to control where people put their workloads and all that. But if we made it so that it was one host per region and we would expose how many nodes we currently have and how many we could have on a minute by minute basis, then we've now succeeded in transparently showing what's under the hood for us. And so that's what I want to know from these people. Like, they say they want to be anti-corruption, sure, but like a transparent data system, which is possible in the architecture I mentioned, what is their interest in that? Would that cause them to reel back from it, or is it something that would be embraced or welcomed?
Well, there's two levels to that, isn't there? You can be transparent about your road network, and be completely obfuscated from whether you're delivering timber or cocaine.
You can hide, yeah, like you can hide what car is traveling, but you can show how many cars, for example.
Right, and that at that application layer, that would be their choice about
Yeah,
how transparent they
it'd be
want to
like
be.
sharing the video surveillance network of the road network, but you obfuscate all the license plates.
Right, right. Um, and that obfuscation would be a choice per user, and the user could be a state actor.
Yeah, yeah, and so what what it, we need, and so those are basically three different questions that you need to get out of these people. Is computation okay if denial is taken care of? How much are they willing to expose under the hood if it was possible to expose it under the hood? And is it acceptable to have their data spread all around the world if they had a mechanism to make sure that it would not be denied from them, like their
I
data
think
being
that
used?
I think that final one, denial and access by other actors,
Yeah.
I think is the thing that they care about. But I'll ask the question. But the denial thing is you never want to be held to ransom.
Mm,
Have a worldwide rug pull.
mm, mm.
Um, so, federal court tells AWS to sanction Tanzania.
Mm.
Not cool.
Not cool, right? And then you, even if they gave you a month to get off, like, could you migrate your services in that time?
Right.
Would your constituents see disrupted service levels during that migration? Probably.
Yeah. So there's that part of data sovereignty, which is this is our data, and
Mm,
nobody can deny us access to it,
mm,
no matter who says what. And
mm.
the second thing is the access. Nobody can exploit it,
Right.
which is a different question.
Yeah. Yeah. So these are because if we get positive answers on all of those things, then these are 100% our people. Because I think that the group of people like in the Ukraine, like Tifu, would answer very positively in our favor to all of those questions if asked of them, because they, those things make sense in their environment.
I agree. And we could, you know, abstract that to war fabric. Anyone at war doesn't want anyone else exploiting their data and doesn't
Yeah.
want anyone else deciding, I'm going to turn off Starlink for 2 days or
Mm.
whatever.
But what they might want is they still need the intelligence and they still need the processing, so they might be prepared to allow that to be processed by someone who promises to be confidential, but it's not as damaging if they leak that data as it is if they cut them off from that data.
Right, which is the, what was the term you used? When we're talking about separate nodes with
Segregation?
segregation. Yes.
Segregation of
Um,
data, yeah, so that no one data processor has the whole picture of you. Only you can map everything together.
right. And I think there's probably only one other which they'll be interested in talking about is cost. But again, as I was saying, AWS sounds cheap, but there's a
It's not
huge
cheap.
infrastructure.
It's not cheap at all. Whereas what
It's
we're
not.
offering
It's
is
not tin
scavenger
level.
level. It's scavenger level cheap
I mean, when you think about it, if you're scavenging CPU and storage from pre-existing
from every
hardware,
government
all you're
computer.
interested, yeah, the only cost is in the network and energy
It would be
layers.
interesting to do a study on to say, look, can we get some rough ideas on how many actual desktops and phones the Tanzanian government has, and then do a study that says, well, here's actually the spare compute and storage um, that's actually sitting latent in your buildings right now. You know, how much would that cost to build that capacity out in a data center?
I would be stunned, and yes, I think that's a good idea. I would be stunned if the latent compute capacity, even inside of their own country borders, is anything else of an order of magnitude more than the vast cost of building a data center or two.
Yeah, right. And then you spread that out to citizens where it's like, well, now citizens can, as part of their service to the country, can operate these government sanctioned nodes and you could get paid for it. Like, because the government was going to pay someone, they were going to pay the data center guy, or they were going to pay for the power and the bills of scavenging from their own equipment. So that sets a floor price. And they're like, well,
Yeah,
if you can do it for cheaper than that, we'll pay you.
yeah. Well, this guy's he's quite skilled in the art, and so he's probably going to bring up security concerns of distribution
Yeah, but
for sure.
that's easily matched. There's first of all, permission networks mean that nobody outside the network gets the data, but then there is some level of broadly available data that you'd be happy encrypting. Um, and there's some data that should be entirely public, but this system allows you to verify that it was actually the correct data, because that's also quite hard to do, if especially if all you've got is an S3 bucket and someone says, okay, show me the blah 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 contract, and you're like, here, and they're like, how do I know that this hasn't been tampered with? And you're like, oh, hang on, let me fire up the separate system that may or may not have an attestation
Yeah,
record of this thing. Hold on. But
yeah,
for us, that's just the data. Like, that's just there immediately.
yeah. Current ways of proving integrity are really quite poor.
They're very poor. So proof of existence or proof of integrity are incredibly difficult to do right now, but we're offering that as like, you can't not have it. Like, you must have that feature with us. We don't allow it to, like, the way that we have stumbled upon or ended up with consensus demands these quite clean properties like integrity, like proof of existence, like the timestamp that the hash first became known to the blockchain. Like, it becomes very, very elegant because the minimum it needs to operate is actually the rest of the computing properties you wanted from a perfect computer.
Well, yes, and I mean this is what we're kind of edging towards, isn't it? Because we talked
Was
about
that a pun? Yeah.
the yeah the dark edge being the perfect computer
Yeah.
uh, that will survive everything except maybe a big asteroid hitting the Earth or something monumental or less extreme, a fundamental architectural problem.
That's cold.
Um,
But yeah, okay. Yeah. Um so those are now another level of questioning that you are now able to, or that you we need to know from these
yeah,
different groups. But it sort of brings to light more the quality of what we're able to offer now. And if I may, I want to go through a couple more examples in detail, because I think the details help highlight the simplicity with which we extract some very advanced features, provided you use it the right way.
Okay.
So an S3 bucket. Oh, sorry.
Sorry,
Yep.
just before you start that, to round that off. So I'll talk to this chap. I'll review this recording, and I'll get back to you. I didn't want that as a hanging task, so I'll do
Okay.
that.
Okay, great. So, to summarize what I want to do, I want to show you an S3 bucket service. I want to detail how hard it is to set up a new S3 bucket service and talk about what we might offer in this space. And then I want to talk about email and where we can offer a simplifying type of an architecture there, but also talk about how the coming of LLMs makes it possible to simplify some of the really thorny parts of a production grade, maintained and upgradable system where uptime is of a concern. And I think that LLMs can start to help us a lot with that.
Okay.
All right, so I'll work backwards. I'll go with email first. Email is a good one because the number of emails that get sent in the world are still going up. It's probably almost the most popular means of communication around the world, tragically so. But when you go to run an email server, it's so amazingly hard that you're almost always pushed off to use an API service provider like Amazon or SendGrid or Mailgun or all of these things, because they're like, oh, you need your dedicated IP, you need your Mail Transport Authority reputation, you need your spam filtering, you need this, you need that, right? And I'm like, well, maybe I do, maybe I don't. But first of all, again, those services are offering this promise of uptime. And we all know that these kinds of services, yeah, they're great until they're not great. Like if you find they're not there one day and then you go, hey, you're supposed to be there. And now like, sorry, we had an outage beyond our control, blah, 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 blah. And you're like, I want my money back.
T's and C's have no teeth. So it's like,
yeah. And then you're like, well, I guess I just sit here and live with it. Or if you're sitting there trying to make this choice as a purchaser of these services and you're like, how do I measure who's more reliable versus SendGrid versus AWS? How do I know what's happening under the hood, whether I like their architecture or not? How do I know that they're not overcharging me for what they offer? Like, what are their base costs? I don't mind people making margin.
Or just a bunch of charlatans completely lying. Yeah.
Right. Like, really, it's just one dusty server in the corner, and they're like 999 uptime, but right. And then you find out that some dude like reconfigured a router in Amazon East and took the internet offline, and you're like, well, where's your like 99s now? Like,
yeah, it's an illusion.
Yeah, and that goes back to the heart of what I really do think blockchain is capable of solving. It's not that it suddenly gives us like 10 nines. It's just that whatever the probability works out to, it will be reliably that. And like reliably 3 nines is better than theoretically 12 nines, in my opinion.
Yes. Yeah. And personally, dealt with instances where it all boiled down to some construction worker taking, a pile driver through a cable.
Right. Exactly.
And then everything
and those are actually non-malicious things.
Yeah.
Imagine what happens to the reliability rating of these data centers when things get malicious. What happens when climate events kick in? Like all these kinds of issues. And I'm because there's also another gentle aspect that I want to touch on, which is the correlation, the connection between understanding the cause of a fault and seeing the fault happen. And like, if you can understand, if you feel like you understand the system, and then when a fault happens, you're like, I get that. that's worthwhile because these like 9 9s are disconnected from my experience. I'm like, I have no idea what's happening under the hood that makes you say 9 9s. And so when
Hmm.
a fault does happen, I'm like, well, I how do I relate to that? Those are just telephone numbers. They have no anchoring in the reality that I experience. It's like when you wait for an Uber to come get you, the fact that you can see where it is on the map is worth way more than maybe the local cab company was going to be quicker. But the fact that I didn't understand what was involved in wait and them getting to me means that I don't feel as safe. Like
Oh, that's a really, really interesting point that
there's
you
something
raised.
about showing you how it works and you understanding it, and you're like, oh yeah, I get how that works. Oh yeah, I get that.
So if your Uber driver takes 10 extra minutes to get to you,
Yeah,
and then you go into maps and say, ah, there's an accident on this road,
yeah,
and there's a, you know, he's going to have to reroute.
yeah.
That's kind of all right
It's all right,
because you
and
can
it's
make
just
you can make decisions. You can say,
yeah.
actually, don't bother. I'm going to
You
walk.
can yeah, right, absolutely. You can put a time limit on it. You're like, oh well, either if he doesn't start moving in 5 minutes, then he's not going to get through for hours. So blah blah. But there's also the element of I can pass that on. Like if I was running a tour of a city and I had some people with me and we're waiting for the Uber and I can see and I'm like, oh look, on that road there's an accident like every 5 minutes. Like I can pitch why it's okay that that happened. But with an opaque system that's like 9 9s and it goes offline, what do I tell my customers? I'm like, shouldn't have happened. They're like, mate, it did happen. It's happening right now. And you're like, yeah, I guess I'll just join the angry mob that yells at them. And then you feel even worse because you are powerless. You can't do anything.
It's like the helplessness of trust. The more trust that you need to put in other
Yeah,
people, the more helpless you are.
right, right. It's 9 9s, but you're helpless. Whereas,
Yeah.
like, 3 9s, but you could drive home, grab a computer from home, plug it in, get the hard drive out
Right.
of the dead thing, and then have it running. Like,
Right.
there's value in the fact that you can do something. You're not entirely helpless. And by the way, 9 9s isn't 100. Like, why isn't it 100? Like, I'm completely my helplessness is 100.
Well, there's something you've struck on here that really is quite important. So, let's go 5 9s. 5 9s is there almost arbitrarily because of the chain of trust. It's like, oh, we've got Joe, we've done power supplies, blah, 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 all that kind of thing, UPS.
Yeah.
Um, but you don't expose that, you just expose a number. Now, that number is only really enforced in the contract. And it's like, well, what do I get back if it goes down? Your The cost to you might be far higher than the cost of the contract.
Yeah. Yeah, absolutely.
And you're sitting there on conference calls, let's say if it's a large organization, sitting there on conference calls, shouting at people, saying, right,
Right.
I need a sit rep every hour
That's
because
right.
there's nothing else to do.
I know. And then the worst thing of all, the humbling shame of it all, is that when it's all over, you got to sit back down and go, you're like, what changed? And you're like, nothing.
Mm-hmm.
What are we doing next month? We're sticking with S3. Like, wait, why not? And like, well, because it costs this much to move. And then
Right.
everyone looks around each other
It
and
becomes
they're
a
like,
stickiness there.
right. And it's like, oh, I guess we're bitches. Yep, that's right.
Right. And we're talking about honest, outages, but there can be dishonest outages.
Well, that nines rating is not practical. Like, it's not. It's a calculation based on ideal conditions, and then you've combined a bunch of calculations from ideal conditions, but the fact that you combined things at all now makes it unideal. And then
Yes.
there's like the real world, like a guy with a digger, a couple of guys with some drones. Like,
And Murphy's Law.
all these things, right? And so it's a lie, really. It's a lie.
So,
But the
so
lack of an alternative means you got to swallow it. Because what else are you going to do?
I love your analogy or your point being right. This critical system that we paid a lot of money for has gone down. Can we go down to the local store, get a whole bunch of servers, turn them on, and just sort it out for ourselves while
Yeah,
these guys sort it out?
yeah. But it's also like single choke point. Like if you had every user spread across multiple computers, you're not going to have a case where every user goes down. But if you've got a
That's right.
central bucket, you can lose everyone in one day.
Or if you had a global network, assuming the global network is still up, and you've decided, oh, we can run on 3 nodes, and oh, we got an outage, and you got a slider and saying, you know what, next 2 days, I'm just going to go for 20 nodes.
Yeah. Or if there's a
Until
storm coming, right? If there's a storm coming, you're like, okay, double the
right,
node capacity, right? And then you can tweak you can have an LLM making very complex provisioning decisions that are probably what you'd do anyway, but it's just doing it tirelessly. It's like there's a
yes,
storm coming
because
in, I need the
yeah,
nodes doubled. Okay, last time we lost a third of the capacity when someone hit a tree down this road. You're like, okay, so we need more capacity over here, and we need to spread this workload over here. Okay, right? Like it's like the LLMs can do what took incredibly complicated software to do, and it's a good place to deploy an LLM because there's no right answer. The answer is if you sort of adjusted your provisioning, that's pretty good. Whereas to make
yeah,
a program to do that and even get close to optimal without some wild race condition where it provisioned everything on this one box randomly, that's hard, man. So we can actually deliver services in this model that have the self-sovereignty requirement. They've got incredible uptime, but it's understandable uptime. Like it's touchable or fathomable. It's also interrogatable. Like I can actually look under the hood and be like, what is the uptime stats on this node you're running, AWS? And you're like, see the latency, it's gone up. That thing stalls occasionally. I would take that as a health signal. That node is ailing. Ailing comes before failing. Why don't we do something about it? And worst, the best of all, because you can run hybrid, you can have a box sitting on your own premise. So at last resort, you're like, well, I guess all this fancy stuff is worthless because, Bob over there just drove over the fiber coming into our building and we don't have dual redundant fiber. The data center's got dual redundant everything, but we got this one fiber line. Sorry. And now like a team of 100 are sitting idle talking about the cricket. But if you had a server that you kept an eye on, like I personally have good experience with the uptime of my servers. I think my own servers would approach 4 nines of uptime for the most part,
but
because I can reach out and touch them.
the cool thing about it though is you don't need to reach out and touch them because you can have an LLM who's tasked with just making it better.
Yeah, yeah,
Doesn't need to be perfect. Just
yeah.
get it better
What I
than
was
it is.
meaning with the reach out and touch bit is that's the ultimate in reliability. Is that I can run something on prem, which means I can go to the local computer store or go home and grab a spare. And if
Right.
if the
Yeah.
system goes offline and I was running an on-prem node, that's kind of my fault. Like
Yeah. You
that's
imagine
legitimately my fault.
Hurricane Katrina hits and you've got an old server sitting in the back with a connection and a diesel generator. Um,
Right.
you can get something that is really shaky, but still you can accept the fact that it's really shaky
Mm,
in the time being.
mm. So
But
these are
you've
these
got
are
something you can do.
yeah, this class
Hmm.
of properties is like it's like graceful failure it's distributed failure. So if you follow that second principle and split up your blockchain domains into their usage, so like one per user or whatever. So you've also got this malleable load as opposed to right, an atomic load is one that it's like you're running my entire cluster of virtual machines, and without that whole thing, you might as well not run any of them. But if you followed good principles, you're like, well, it's these little grains of sand spread around everywhere, and running 80% of them is far better than running none of them. So, like
I'm loving this. I'm loving this.
it makes it that the word for it in metallurgy is toughness, whereas a brittle, you can have a very strong material that's brittle, so its failure mode is that it will snap, and it's like it's really good, and then suddenly it's like zero. But toughness or ductility of a system is that even when it's failed, like it's been bent or pulled too hard, it deforms gracefully. It's still taking some load, and even right until you pull it far apart, it's still taking some load, just ever decreased amounts. And so the ductility of the resilience of your system is a type of measure that isn't really captured anywhere, because there are very poor examples of ductile failures in the computing world. But if you followed that second principle, which is the separation of workloads, then now your workload is able to ductilely deform, and you can even like prioritize some. You're like, we've only got capacity of 80%. Who hasn't logged in the last 2 years? Okay, ditch them first. Like you can actually make smart decisions about how the ductility is applied.
I love that. As an aside, I love the metallurgy analogy. As an owner of probably too many swords that would be reasonable, I love that analogy. But it also seems to lend itself as far as a solution to countries like in East Africa, where cost is a concern, availability is patchy but generally okay. The acceptance of degradation probably is, more acceptable. But they still want the data sovereignty
Yeah.
that it offers.
Yeah. So they have to accept degraded service sometimes, and so they need a system that can tolerate that or can work with it. And that's us.
Yeah.
That's no cloud provider has that. Right? And then there's also the aspect of like I mean, look, if you could get the data distributed amongst the people themselves,